Steve here with SSI. Today I want to talk to you about Atlas lathe carriage stops. Now what brought this on is I have a friend down in Texas. His name is also Steve, and this video is for you, buddy. Now, he was asking me for a multi-position carriage stop for an Atlas lathe. Well, let's start at the beginning. This is one of the first carriage stops I ever built for an Atlas lathe. Single position, it's not calibrated, made out of aluminum, since that was an easy material at the time to use, and over the years it has gotten a lot of wear and usage. You can see there, this is actually starting to bulge out, mainly because this distance is too short. Now, you see this screw go through here. You're probably thinking, well, you never ever put a screw of metal up against a metal lathe. You're correct. So this was a piece of copper that gets stuck in between, just like so. So this keeps the steel from steel contact from happening. Well, this carriage stop has served its purpose. So my next innovation was this right here. This is a single position carriage stop. This one is calibrated. I calibrated it myself. I will do a video on how to do that. And I used the same principle using this type of clamp. So a milled piece of copper against the way. Now one thing I did different here was this length and this length are different. One, it gives me added material out past the screw holes so these don't do what the aluminum one did. And it's easier to slide up and down the way without it falling off. Now, the distance between the rat gear and the end of the way on an Atlas lathe of my style is 3/8 of an inch. So that's what this distance is. This distance is roughly ½ inch. Now, one thing you can do once you get one of these made, if you want to make one, is after that you can make one of these little guys. This one is actually out of a piece of scrap material I had, and it was a quick mock-up. As you can tell, these legs are a lot thinner. Still the same style, using the copper plate in between. But this is an indicator holder. So lock it in place, lock it on your carriage. You can track the movements of your carriage. First thing I want to talk about is the style of clamp I used this time around. This clamp is actually a clamp style. Two large bolts help clamp it to the machine. Of course, it's got a large diameter hole, and this is also made from steel. This holds the multiple positions. There's only 3. For a lot of the work that I do, 3 positions is plenty good enough for everything that I need this application for. Also, this is indented for every position that I need it. So there's no guesstimate on when it rotates or it locks into place. This piece is the thumb knob on the back side, so you can rotate it. This is a felt washer that goes in between this piece and the other side. This is soaked in baby oil, so it'll be slick and keep the wear down. Whenever I get it together and actually show you how to use it, then it'll start making a lot more sense. This piece that you probably saw laying over there is not that big a deal. This was actually a failure during the process. My original idea was to have this rotate and lock in positions. Well, these 2 holes on top are not in the right place, being this small of a diameter. So this piece is out, the new piece got made. So I've already started on it, as you can tell. Well, I didn't want to bore you with the details of fly cutting or squaring a piece of stock. Now I may put in how I decided to put in these holes and the positions of these holes. And what I've got here, depending on what I want to do, I want to space these holes out across here, right? So what I've got to do is I've got to figure out where I want them and how much clearance I'll have actually between the holes. Now this is 1 inch 415 thousandths, so we can take 1.415, divide it by 3, and we can do it, that ain't right, 1.415, that's plus, divided by 3, there we go, equals 471,006 That would be the distance from the side to the center of the hole, to the next center of the hole, to the next side. So if we did that, that wouldn't leave us enough room between center to center distance of the hole. The reason is, our size that we wanted to use for the base of the bolt, we're going to use 3/8 for the square. The base of the bolt was going to be 600 thousandths. So that would be 300 on one side and 300 on the other. Between the two would be 600. They would touch in the center. So we can't do that. So my idea is I'm going to give myself 100 thousandths from the edge of this to the edge of the bottom portion of the bolt. Kind of a washer to represent what it would be, because we're going to have a 3/8 hex. Now this washer is actually bigger than 600 thousandths. It's 630, I believe. It's the closest thing I had. But I wanted to, if this was the base of the bolt with the 3/8 sticking out on top, I would want 100 thousandths between this edge and the edge of the bolt. So that would be 300 from the center over to the edge plus 100. So it would be 400 thousandths. So we know that we're going to have two of those. So we've got 1 inch 415 thousandths is our total width across our piece. We're going to take away 400 twice, because we're doing it on each side. That'd be 800 thousandths. That gives us 615 thousandths for left between center and center, in between. So we're going to have 600 thousandths basically taken up by the bottom portions of our bolt. So it should give us 15 thousandths in between, left over. Enough for clearance anyway. So that's about as close as I could get and give myself a little bit of aesthetics at the same time. So what I've done here, I'm going to start marking my lines to drill my holes. So I know it's going to be 400 thousandths from this edge and 400 thousandths from this edge is going to be 2 scribe lines. So I've already got the nice vernier height gauge with my carbide scriber at 400 thousandths, and I'm going to go ahead and mark them. Give myself enough room there. So there's my 400 thousandths marks right there. 400 thousandths from side to side. So now I've got to figure my distance from the edge of this back. So basically it's just going to be 100 thousandths plus whatever my bolt diameter I decide to do is. Then I'll scribe that on the face of this across, and that'll give me my 2 X's to drill my holes all the way through this piece. So I'll get this figured out and get back with you. Okay, this is what I've figured out so far. I have this distance from the top of this to this landing is exactly 1/2 inch. It's 500,000ths of an inch. I'm going to add 100 because I want wall clearance, or a wall there between the 2 pieces. That should give me enough room. Plus the 1/2 of 3/8, which is 187.5. 187 thousandths 5/10. I'm going to bump that up to 190. Just to make it a round number. So we got 500 thousandths plus 100 thousandths. That'll make it 600. We take 600 thousandths plus 190 thousandths. Gives us 790 thousandths, right? Right. Okay. Didn't need a calculator, just making sure you could see it. Notice I don't have a granite surface plate. I do have a piece of granite. It's a headstone, well, part of a headstone. It's been broken off or cut off for me. I use it from time to time. It's fairly narrow, all of about 6 inches wide, but it's about 6 inches thick too. So it's a big chunk, and I use it for smaller things. This is a piece of polished floor tile is really all that is. It's on a flat surface. It's a flat surface. You know, it's not perfectly flat, I'm sure, but you see that stripe of light there. That's one way you can always tell how flat something actually is put it in the light. And if this beam is broken or distorted in any kind of way, that means it's definitely not flat. That light's pretty straight in there. So I have fair enough confidence in it that it's straight enough for my needs at this point in time. Later on, I'm sure I'll get a granite surface plate of some kind. But in the meantime, this is what I'm using. So from this edge, which is with our landing, up is 790 thousandths to our bolt centers. The height gauge is already set up for that, so we'll just scribe a line. And there we go. Now, I didn't need to scribe this near as far as I did, but I don't care. So what I should be able to do is lay my washers on here, and they are going to touch since they are bigger. I don't know if you can see that. Remember, these washers are bigger than the 600 thousandths. They're 635 to be exact. But you can kind of tell that's what's going to happen. Is one of them is fairly lined up, the other one's a little off because it's being pushed over, so the math should be right. If I can get this one lined up a little bit better, kind of give you an idea. There will be, whoops, there's the center of it. There'll be some edge distance there. It's actually less than 100 here, but that kind of gives you an idea of what we're looking at. Kind of a mock-up in so many words. So one thing you can always do is after you've done your math and you kind of want to see what it's going to look like before you actually do it, like in this case, you can mock it up with a little piece or part, and that should help you kind of figure it out as you go along. Now I know 100 thousandths doesn't sound like a whole lot of space, but it's a pretty big chunk, and that should be enough wall thickness for that bolt to never ever chew through to the other side. Since we're going to use a 3/8 bolt through there, 3/8 16, it'll probably just be a 3/8 collared bolt with some threads at the end. Not collared, but shouldered, I'm sorry. 3/8 shouldered bolt with some threads at the end of it, all the way through that piece. So I'll meet you over at the drill press and we'll drill a couple of holes. Okay, we're over at the drill press. As you can see, I've already dotted that thing just to make sure it's going to be where I want it to be. Now, for those of you who watched my last video about the camera mount, oops, I'm sure you remember this little guy. That's what I used to line him up with. Homemade little centering scope. Helps out quite a bit. Makes things faster. So I'm going to ream this thing to 3/8, but first I have a piloted reamer here that I'm going to use. The pilot is this size drill bit, which is a T. So I'm going to drill the hole first, well, I say first, I'm going to spot it first. Then I'll go ahead and drill it. Here, my little oil can. So I'll spot the hole, then I'll drill the hole, then I'll ream it, and then I'll do the other one off camera. That's really about all you need to get that thing started. Just used a standard little spotting bit. Nothing real special. You can also use a center drill. No problem with that. The reason I use the spotting drill is the reamer is so long that the distance for the quill here, sometimes they don't reach. It just depends. Depends on which one I'm using. So just see about that. So there is the actual drilled hole. And if you don't have any reamers, a drilled hole's fine. It'll be a little rougher. I just happen to have a reamer. A piloted reamer at that. So, unlucky. Well, it doesn't look like the straightest thing, does it? thing about those, they just run right through it. So I'll drill the other hole off camera, dream and reel the other hole off camera, and show you the results. But I think you can tell by what you see in the camera there that it is quite a bit better. Okay, we are done with the cleanup and a little bit of deburring, and here's the finished product. You can kind of see down inside those holes a little bit how nice and smooth that is.